This is going to be a much more interesting talk. I'm starting to read a lot about AC current and circuits, things I borrowed off hyperphysics. Wikipedia articles tend to be a bit vague and poorly written. Hyperphysics tends to be a lot better. But let's cut to the chase here. A relaxation oscillator. I didn't even write it up here. In my previous video, I talked about why pulsars are not stars. Obviously, they're just too weird. Okay. Now, a relaxation oscillator works like this. You have a battery, which is a DC source for EMF. You have your resistor. You have your capacitor, which is two charged plates or whatever energy storage device you want to use. And then you have your bulb with a 5-volt firing threshold. So when this capacitor reaches 5 volts in electrical potential, it releases the energy. The bulb uses it up, and then it sets back to normal again. And the resistor is what controls the electrical flow. In a diagram, this would be the volts, this would be the time, and the period is between these two waveforms. So you would have the capacitor charging, gaining charge, okay? And then it reaches the threshold of 5 volts. Then it discharges, boom, creates a pulse of light. And then it goes back down to normal, and then it charges back up again, boom, pulse of light. And then it happens over a set amount of time, depending on what you have your resistor set at, how much the capacitor can store in charge. And basically, it depends on the amount of inductance the capacitor has. So say you have a copper wire, okay, and you have a 6-volt source right here, charging up that copper wire. And it will produce a corresponding magnetic field as well. The magnetic flux of that copper wire can vary based off how much current is going through it, and if it has an iron core. Now, air core and iron cores are different. I'll go into that in another video. But if you stick iron in there, the magnetic flux will increase. Say you have an iron bar in between that copper, the magnetic flux will get a lot stronger. Okay? All right. So, to reference this to pulsars, now, I'm not too sure what kind of waveform the pulsars have. I have to read more articles like this. This was written in 1996. It says hard X-ray spectroscopy and pulsar phase analysis of the bursting X-ray pulsar, GRO, J1744, yada, 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 yada. But they go over this, and I have to learn how to read all this. Basically, you have, what's called a sinusoidal wave. I'm learning that in my AC book. But that sinusoidal wave would be the magnetic flux. And obviously, I have yet to explain that too. But there would be two different kinds. There would be the magnetic flux, and there would also be the actual current that flows through the pulsar, releasing the flash. But I think one of the more important things that I didn't see before was that there's two large properties of a pulsar that I just realized as I was writing this. There's the jet, which goes in both directions. You have a jet that moves through the pulsar, which propels the matter to almost luminal velocities. And then you have the pulses, which, act as the relaxation oscillator of the pulsar itself. That's what makes it pulse. But as it pulses, there's a jet that moves through the center of the pulsar. That's why I wanted to think that the pulsar structure is more like a torus. And if you have an iron core there, or any kind of material that can increase the flux of the material, such as the jet going through. Now, that's really out there. So basically you have the electrical current that's wrapped around inside that torus-shaped configuration, and somehow it propels the jet to go in both directions. Now, I say it's both directions because if the jet were to go in this direction, the pulsar would actually move, because obviously it would be propelling it just like a rocket. And it would cause the jet, if the jet's going this way, obviously the pulsar would move this way. But if the jet is going down, then the pulsar would take off and go up here. And depending on which way the jet is oriented will determine where the pulsar is headed, which could explain a hyperpulsar, which is leaving the Milky Way galaxy. I had to look that up, but basically that's how the pulsar ejects itself from a galaxy. Now, another point I wanted to bring across is that I found this really interesting, is that we have relaxation oscillators inside of our own bodies as well. There's it's called the sinoatrial node. It's in the upper right-hand part of the heart, and it acts as a natural pacemaker. And it's not exactly, just straightforward like this. Obviously, the heart has a lot of very complex nerves and, whatnot. But basically, it acts as a relaxation oscillator, and it pulses, and it sends electrical pulses to your heart, telling it when to beat. Very, very, very interesting stuff. So basically, that is what causes the heartbeat. Now, I'm a big thing on natural philosophy, and if I look at the stars and I see something that beats like a heart, chances are there's going to be something in nature that does the same thing and that keeps other things running, like the circulatory system. That's what the SA node does. Now, that's why I wanted to think that a pulsar is the heartbeat of a new galaxy. That's the object that is the central structure to a galaxy. After it ejects itself, depending on which direction those jets are going, some kind of mechanism causes that pulsar to transform matter, or transform all of its energy stored as magnetic flux into almost luminal jets to create the process, of fusion, because that's where the necessary velocity comes from for sequential neutron capture. Sequential neutron capture meaning you take an atom and you slam it really hard against another one, or you take neutrons and you slam them against atoms and they fuse together. They make heavier and heavier elements. This is why I think the fusion model of stars is, bogus. It doesn't happen there. It happens in the jets of pulsars, which are embryonic galaxies. But anyways, I think I made this long enough. There's so much more to talk about. I just don't want to keep on going because I have a limit on how much I can record on this iPhone. But today is June 30th, 2015.